Hello, today we look at a linked list of unique values as set. So let's start with our decision tree. I linked the playlist and the presentation that I use here. And yeah, that is what you actually should do at the start of each project or sub-project. What kind of containers do I actually need? Handling game data, meaning for me mostly a struct or an object, depending if I have simple or complex data. That is the kind of basis that you normally put in your map, in your set, in your array. If I have non-transactional data, so master data that are fixed and stable, I use a data table. We will see that today in the project. Do I have first in, first out queues that I want to use? Not in this case. We want to end up with a set, so we ignore that point. But we have here the set. We want to have uniqueness enforced, so every single item in my set is unique somehow. And then we go to the set. Otherwise, we would move on either to array or maps or whatever. The set is this linked list of different unique items. And that is what we want to have a look at today. This hashing, that is the unique fingerprint of each set. The hash function is something that you have to implement for your struct or for your object. It's quite easy to do, but that gives you actually decision power. What is a unique object? You can be lazy and just use a GUID and hash that, or you have more elaborate logic here. The TSet is very fast, so constant time for adding, finding, removing elements, in contrast to an array that can get extremely slow if you add elements to it. So better use the set there if you have a list of unique values. The uniqueness, as I say, is defined by your hash function. So the values could be equal, just the GUID different, for example. So that is also a possibility that I use from time to time. Filtering and sorting is quite easy with a set. That is something we will have a look at. I put the Pastebin that I use in the project in here. And again, for all these things that you exposed, they are templates in C#, but not in the blueprint, meaning you only can use them for one specified object or struct. And if you need another one that you want to put into a set, you have to define the set again for that struct or object. We will use this Pastebin here, this exposed TSet to blueprint, including custom search and sorting. So you just go there, copy it, and then we will implement it. We start with a very empty third-person project. We say C++ and create a project from here. Here we are. And now we are in the project folder. Here's the folder. We have to clean it up first. For that, I always have this kind of mini batch files that are removing binaries, derived, intermediate, and saved. Just execute it, and here we are. So that is my clean project. Very, very important before you add source files. Then I go into my source file. I right-click and say folder and add a new one called container. That is the folder where I will put all the containers, like sets for all different objects or maps or whatever in there. And here we just create a new file. Copy the Pastebin that we got in here, copy that, paste it here, and save it in the newly created directory. So file, save as, and here we go. The name is very important because we point to it in the code. So here it's tset.h, H for header file in C++. And here on the left you see it's coming up. And yeah, let's try it out. And here, right click, generate Visual Studio files. There you see the saved and intermediate is recreated, starting the project. Here we are. And then if you have a look into games, you see your game, the TSet test in my case, the source, and here the container folder. And here we are with our tset.h. Okay, let's go through the code. I will structure it a bit, so tackle all. Here we are, it's a bit better for having an overview. First thing, include. The very important thing is here the tset generated h. That has to be exactly your file name, otherwise it will not work. Then we have a kind of small helper structure enum because we want to test our sorting, and to make it easy to use from blueprint we introduce this enum that is used then later for using the blueprint. Here we have our TSet test struct, so a struct that we will use. It's a child of public F table row base. That makes it possible to use it as a base for DataTable, what we will do in this project here. Other than that, the name is extremely important. As I said, that is exactly the one name that we will use here. Properties is a name and number. The constructor is just initializing name and number. And then we have two sections here. This one region is mandatory function. That's extremely important. If you want to use your set, you have to provide a get type hash and you have to provide an override of the double equals signs. Both are necessary, otherwise it will not work. For the get type hash, you can actually define your logic because that is your unique fingerprint. When should your set be seen as unique? And you can use custom logic like here, where I have a type hash from the name and hash combined with a number. You could always use a unique GeoID and hash that. That is what I mostly do, honestly, because then you have some uniqueness. But it could be that you want to have more elaborate logic here. So you could type here, but you have to provide it. Same thing with the double equals. When is a struct seen to be equal? I made a lazy approach here, just saying if the number is equal, the whole struct is equal. I guess you might have more custom logic here, but that is really your deciding factor. When do you see two structs being equal? Both needs to be provided, otherwise the set will not work. Then we defined a couple of sort functions. You can actually use as many as you want. The point is you always return a bool. They need to be static, and you provide two consts. That is a kind of structure 1 and structure 2, A and B, what I called in here. And then just some logic, how would you compare them and how would you return your bool. As I said, that is custom, so meaning you have as many or as less as you need. And, that should be number, not name. And that is what we will use for sorting later. The set test struct is the one that we now use in the whole class as initialization. If you have another one, obviously you have to really search replace the whole class here with a new one. We have a delegate here that is not doing much. It's just firing when certain events are happening, giving back a bool. Then we have the class, that is the set class that we actually use in our blueprint. So it's blueprintable, it's transient, so it's not saved normally because it's something that's not stable. We have a constructor not doing anything. We have two delegates, one delegate for adding and removing to the set from the set. These are events that we can subscribe to in Blueprint. Then we have here our TSet with the TSet test structure. That is something we would change if it's my object that I want to use in the future. And here we have, let's start with the sorting functionality. So we have the set sort, and we provide a enum, this test structure sorting sort that we saw above. And then it gets very easy. We just switch on that, and depending on the enum that we get, we just call one of the static functions of the struct. Makes it extremely elegant to code here, and there's actually no code in the set class itself. And that is how it should be, because your next struct might have different code. Here, we could also use a lambda. Yeah? So not having the code in the struct itself, we could have it here using this lambda functionality. And if you look at the lambda, that is exactly the signature that we use here. Yeah? We have two consts here, and we return a bool. And that is what we could have in the class itself, but it belongs actually as logic to your object, to a struct or whatever you want to use. So meaning that makes it quite easy to call it here. So that was the sorting. We will see it in action soon. Then the standard functions that are the ones that you know from Blueprint: adding, number of values, removing, kind of cleaning, making it empty, but also already providing capacity for a new one. See if an item exists or getting all values. These are the ones that you know from the standard implementation of the template in Blueprint. I repeat, very important, make sure that the file name is exactly the same as your file name, this generated. First thing we want to do is creating a structure for our data, because we want to bring some data in. So let's say data, and here I want to create a data table. So our master data table, that should be struct on top of this test struct that we just saw. So struct is always the base for a data table. We call it DT cities. And I want to bring in a couple of city information with the name and the population that you get from the internet. I link it if you want to reuse it. And we just have here name and number as we saw as properties in our struct. And now let's try to fill it with values. I have a CSV file somewhere. I put it here into resource world city CSV. And if you actually have a look on it, you see it's just really, the row name, that's the city, then the name, also the city, and the population. Altogether, 41K of cities with some information in it. So let's close that again. And here we just want to import. So we set it as a source file. We go to DataTable, say re-import. Oh, for a couple of them seems to be double. Okay, no problem. And yeah, here we are. Starting with Tokyo, seems to be the biggest one still. And going down to, I don't know what that is, 41K of cities with numbers. So that is what we would want to use. And that is how you would work data-driven, always doing data tables and loading them then into your transactional containers. So in the third person party blueprint, just to have something at the beginning of the game, event begin play. First thing I construct, of course, my object from class, and the class would be my TSet that I just defined. And that's not a very original name, so let's scroll down. Yeah, here we are. And let's make it a variable so that we have it stored for later usage. And we call it TSet cities. That's my city set. Okay, looks good. Let's clean up a bit here. Q, okay. So next thing, let's store the data table that we created also into a variable so that we can access it. So we look for data table, say object reference, give it a name, let's say DT for data table cities, and shortly compile it. Then we can set it. And here we go. And here it should be. If it's not there, you press the small tool wheel, and there you say, for example, show plugins if you have it in your plugin folder. Okay, next thing, let's do a sequence here that's a bit better structured. First the one, then the other. So, okay. And next thing we want to do, we want to load all the data from our data table into our set. So first things, let's figure out what kind of row names the data table has. So get data table row names gives you back an array of names. And with that array, we iterate over it with for each and have now each single element. So a single row name, and then we ask the data table for exactly that row name and get the data. So get data table row, and the data table, of course, should be our DT cities. And then we have our out row, and the out row would be exactly our struct. So then we can take our set, say add, a lot of adds, but it is BA container sets. And here we add it to that. And we expect that the struct coming out of the data table is exactly the struct that we use to initialize our set. Otherwise, it will not work. Okay, let's clean up a bit, make it a bit easier to read. So that is our construct TSet. That is our, let's say, DT cities to TSet. We load here. And now I guess we also want to have some indicator if the loading was successful. So let's say after loading, we want to have a message, what was loaded, how many were loaded, and that should be printed out. So we say a print text because we then can use our text format to put a text together. So text format. And if you use text format, you can write whatever you want to print, and everything that is in these curly brackets will be a parameter that you then can fill from the outside world. Makes it much easier than string append or something like that. So if we say loaded, how many cities from data table, cities is my variable, and obviously we use our set and say the number of values here from the set, and that is what we loaded. That was one of the functions we just saw in our C++ file. Cleaning it up a bit and connecting it to the text. Maybe it's just 2 seconds as a standard, so let's give it 10 seconds so that we actually can read it. And here we go. Good, that should print out the total number of values that were loaded into my TSet. Looking good. I think we could try it out already. Let's see. Yeah, 41K of cities from DT are loaded. So that looks very good. So very easy to use it from this non-transactional data into a set where I can start doing things with it. And doing things is what we want to do. I think the most interesting things is really sorting and filtering in sets here. The city set itself can be sorted in different ways because we defined 4 different ways to sort them in the struct. And what you see here is exactly the enum that we use, that we defined, so number and name, descending and ascending. Let's put it name ascending. So after that, I would expect that the set is sorted, and I don't see that yet. So let's look for a way to actually make it something we can see. So getting a breakpoint here so that we can have a look at the set if it actually sorted after that. So we say get all values, and then yeah, it's an array. Let's get, for example, just the length and print that out simply to get a blueprint breakpoint here that we could use. Put it into string. So okay, that's enough. Okay, now I would expect that the name is sorted ascending, starting with A. Putting a breakpoint here. Let's run it. Here we are. That is the values. Values is 41K. That is what we expect. And yeah, looks good. Abazan, Adra, Afrin, yeah, everything starting with A. So meaning the sorting was a success. Next short example, same thing with numbers, ascending. So starting with 0. And here we go again. And again, 41K. And yeah, cities with 0 inhabitants. Whatever. But at the end is Tokyo. Still seems to be the biggest one. Not sure how fresh the numbers are, by the way. Okay, so we see that makes sorting, for example, extremely easy. And looking at the C++ file, that was a couple of lines of code. So that is very, very easy to do. And that is something you cannot do with a standard set implementation of blueprints. Yeah? So worth it, I guess. The next thing that we want to do is not sorting, but filtering. So we had one filter function defined. That is the function the set the get names starting with. So that's a short filter function that gives you back all the different cities that are starting where the name is starting with a substring that you provide here. My substring should be new, so New York I would kind of expect there. Let's reuse the logic that we just created. Too lazy to do it again. And we can get rid of that. That worked already. So I would expect now getting an array back of all the cities starting with new. Let's see how many there are out of my 41K. Let's run that and have a look at the array. Oh, it's only 85 now. And yeah, New York, New Washington, new a lot. Looks good. So meaning, again, this filtering mechanism is quite easy and also very, very powerful if you want to search and work with your different elements here. So that's it more or less for the set. It's kind of, yeah, mostly the same that you get in Blueprint with more powerful functionality. I really recommend using this, thinking about what do you want to use with your data and choosing the right container, because it really can break down hours of work into single line of code in C++, and it's normally much faster than doing it in Blueprints. Okay, I hope, as always, that helps you, and see you soon. Bye.